Hello everyone, welcome to this video. In this video, we shall be looking at various notations which are used for this sequence, right? So in the previous video, we have studied about the definition of sequence through the help of various examples. So we studied that a sequence, it could be regarded as some function whose domain is the set of natural numbers, right? So we can assign for each natural number 1, 2, 3, 4 and so on some member of the given sequence. So, and we use this notation a of n or a subscript n to denote a sequence where what is the small n? This is the given natural number, right? So here for if your n is equal to 1, then we may write the givens. We will be using this notation throughout our course here. So for an, we are using this notation a subscript 1. For 2, we have a2. So here we have a1 as our first term, a2 as the second term, a3 as the third term when we have the value of n as 3, and we keep on doing like this, and so that we have different terms present for our sequence. So that means our sequence becomes a1, a2, a3, a4, a5, a6, and we keep on doing like this at the nth place. So for n is equal to 1, we have a1, for 2 we have a2, for 3 we have a3, for nth place we have an, and we keep on moving like this. So this is our sequence, and in fact in place of this a1, a2, a3, we are just having the numbers. Actually a1, a2, a3, you can treat this to be the name of the given numbers, right? If we wanted to suggest that if we wanted to talk about some particular number inside this, so we have a name for it, and we will be saying or representing that number through the help of that particular name, which is an, right? So here I am talking about this first term, second term, third term, what actually is a term in a sequence. So whatever is the various whatever is the number which is occurring in a sequence, we call that as term. So we have a1 as our first term, this is a second term, this is a third term. So all the different members, different numbers which are appearing in this sequence are termed as term, right? And what does this nth term mean by then? So this nth term, which is denoted by a subscript small n, so this is the number at the nth position of the sequence, right? And we usually call this nth term as the general term of the sequence. So in order to move forward in this chapter, you should learn this thing, that this nth term and general term, what do they represent and what is the formula. I'll be talking about the formula later on in this playlist, right? Next is, what is a finite sequence? Finite sequence is a sequence which has finite number of terms. Now what does we mean by saying finite number of terms? So a sequence in which the number of terms can be counted by us. So that is a that means that sequence would contain finite number of terms, right? So the sequence of first 20 even numbers, that is a finite sequence. Why? Because here first 10 even numbers, let's call that first 10 even numbers. So the first 10 even numbers, they are 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20, right? So here we can count the number of terms. This is first term, so this is a1, this is a2, this is a3, this is a4, this is a5, this is a6, this is a7, this is a8, this is a9 and this is a10, right? And one more question should come to your mind. Why are we using a here? Actually, this is not any formula that we always have to use a. We can use any number in place of a. So bn also represents a sequence, right? an also represents a sequence, cn also represents a sequence, and like this. So here we coming back to this sequence again of first 10 even numbers, we can count all the numbers. In total we have 10 numbers with us. 10 is a finite number, so therefore this sequence is a finite sequence. Next, what is an infinite sequence then? An infinite sequence is the one which contains an infinite number of terms. So that means it would contain the number of terms which we cannot directly count, right? So sequence which is not finite and we may not be able to count the total number of terms within it is called an infinite sequence. For example, if we have the multiple of all the number, we have a sequence in which all the terms are nothing but the multiples of 3, right? So the terms of the sequence would look something like this. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, next term would be 39, next term would be 42, and we keep on doing like this, and we do not know where we will stop doing this because we have infinite numbers with us. And if you start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and you keep on counting like this and you will never stop. So that is why this sequence is an infinite sequence. So I hope you understood what is a finite sequence, infinite sequence, what is the inner term of the sequence, and in general what are the terms of the sequence. In the next video we'll be solving few questions based on these things. So I hope you understood this one. Well, that is it for this video. Thank you for watching.